Welcome to the fifth lesson in Chapter 6 of the Pearson Geometry video series. Lesson 6.5 discusses special parallelograms, the rhombuses and the rectangles. Let's look at the theorems, and then after you've written them down, we'll go over them in a little bit more detail. Let's start with Theorem 6.16. If a parallelogram is a rhombus, then its diagonals are perpendicular bisectors. Okay, Theorem 6.17. If a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. And finally, Theorem 6.18. If a parallelogram is a rectangle, then its diagonals are congruent. Okay, go ahead and pause the video if you need more time to write down the theorems. And then we'll take a look at exactly what they mean. Okay, Theorem 6.16. If a parallelogram is a rhombus, then we know by definition all of the sides are going to be congruent. But according to 6.16, we also know that its diagonals are perpendicular bisectors, which means that they form four right triangles. So when we're looking at example 1, and we want to know what the measure of angle ADE is, okay, so that's going to be this angle right here. So we want to know what this is. We have four right angles. We know that these are bisected, so that means that this angle, or this side, and this side are the same. And we know that these are bisected. So that means that all of our triangles by side, side, side are congruent. So if this angle is 53, so is this one. And then in order to find this angle in a right triangle, since we already know that we are looking at right triangles, and this angle is 53 degrees, then if we take 90 minus 53, then we are going to get 37 degrees. So angle ADE, or the measure of angle ADE, is equal to 37 degrees. So when you're working with rhombuses, you are working with four right triangles. And all of the properties that apply to right triangles then apply to rhombuses. Okay, let's take a look at the next one. All right, in this one, if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So that means that angle 1 is congruent to angle 2. Angle 7 is congruent to angle 8. Angle 3 is congruent to angle 4, but it's also going to be congruent to 1 and 2 because opposite angles in a parallelogram are congruent, which means that angle 5 is going to be congruent to angle 6, but they are also going to be congruent to angle 7 and 8. Okay, and we'll come back to example 2 in just a second. The last theorem, if a parallelogram is a rectangle, then its diagonals are congruent, which means that this diagonal is congruent to this one. Okay, so let's go back up here to example 2. The question is, what is GH? Okay, so if we can figure out what these other ones are, then we'll be able to figure out what GH is. Okay, so let's go ahead, since we know that these two are congruent, we're going to set those equal to each other. So 4x minus 7 is equal to 2x plus 3. Subtract 2x from both sides and we're left with 2x on the left. Add 7 to both sides and we're left with 10 on the right, which means that x is equal to 5. All right, let's go ahead and plug these in. So if we plug this in right here to this side, we get 3 times 5 plus 1. So 3 times 5 is 15 plus 1 equals 16. We already know that all the sides of a rhombus are the same. Therefore, GH must be 16 units. Okay, and example 3. Example 3 says that WXYZ is a square. Okay, so if it's a square, we know that it is a special parallelogram, and we also know that because it's a square, all the sides are the same, so it's also a rhombus. And from Theorem 6.16 up above, if it's a rhombus, then it has perpendicular bisectors, which means that All of these are right triangles in here. So let's take a look at this. If we have WY, which is right here, plus XZ, which is right here, equals 92. And we know that in a rectangle, the diagonals are congruent. That means that we're looking at 92 when you add them together, so you divide them by 2. So 92 divided by 2 is equal to 46, which means that WY is 46 and XZ is 46. Now, since they're bisected, that means each one of these sides is going to be half that. So we're looking at 23. Okay, we want to find the area of WPZ. So we want to find this shaded area right here. So first of all, we already know that we have a right triangle. So that means that this is your altitude or your height. This is your base, and the area of a rectangle is 1/2 the base times the height. So we're looking at area is equal to 1/2 the base, which is 23, times the height, which is 23. And when you multiply those out, you're going to end up with an area of about 264.5 units. Okay, go ahead and flip this over, and let's see what we have on the other side. Okay, so if the quadrilateral in example 4 is a rhombus, what is the measure of MNO? Okay, so MNO is going to be right here. Okay, so if it's a rhombus, then it's also a parallelogram. So if we add 62 and 62, then we are going to get 124. Okay, so that means that all of this is 124. Now, because it's a parallelogram, all of this plus all of this should be supplementary. So if we take 180 minus 124, we are going to get 56. Okay, so that means that all of this right here is 56. So the measure of angle MNO is equal to 56 degrees. Okay. Now in part B, it says the quadrilateral is a rhombus. Okay, so again, we know all the sides are the same, and we also know that these are 4 right triangles. What is QT? Okay, so QT is going to be right here. So we know that 3y minus 1 is equal to 2y plus 3. So if we figure out what y equals by setting these equal to each other, we can plug it into here, which is the length of QS, and take half, which is the length of QT. So let's try that. So we've got 3y minus 1 is equal to 2y plus 3. Okay, we're going to subtract 2y from both sides, leaving us with y on the left. We're going to add 1 to both sides, leaving us with 4 on the right. Okay, so we know that y is equal to 4. Now let's plug it in up here. So we get 5 times 4 minus 4. Okay, 5 times 4 minus 4 is going to be 20 minus 4 is 16. Okay, so that means that QS is equal to 16. So let's divide that by 2, which equals 8, which means that QT is going to equal 8. Okay, example 5. A carpenter needs to check the gate his apprentice built to be sure it's rectangular. The diagonals measure 52 inches and 53 inches. Is the gate rectangular? Okay, so one is 52, one is 53. According to our theorems, if this is a rectangle, then the diagonals should be congruent. So we're going to have to say no, the diagonals are not congruent. Oops. Okay. Now, example 6. A rectangle with area 1,600 meters squared is 4 times as long as it is wide. What is the sum of the diagonals? Okay, so first of all, this is going to be easier if we draw a picture. Okay, so we've got one side is 4 times as long as it is wide. So this is the longer side. So we don't know how wide it is. Let's call it x, and that means that this is 4x. Okay, and the area is going to be 4x times x, okay? Base times height, so we're looking at 4x squared. So area is equal to 4x squared. And 4x squared is equal to 1,600. So let's divide this by 4 first. So if we divide both sides by 4, we're going to be left with x squared equals 400. Okay, now we want to take the square root of that, both sides. So the square root of x squared is x. Square root of 400 would be positive and negative 20, but a negative is not going to work because we can't have a negative distance. So it's just going to be positive 20. Okay, so now we know that this 4x is really 4 times 20, which is 80, and this x is equal to 20, so we know that our rectangle is 20 by 80. Okay, so let's draw a diagonal. We have a right triangle right here. Whenever we have a right triangle and we're looking for sides, we can fall back on Pythag. So we're going to say, since this is one leg and this is the other leg, and we're looking for the hypotenuse, we're going to say 20 squared plus 80 squared, which is going to be equal to 400 plus 6,400, which is equal to 6,800. So that diagonal is going to be in the neighborhood of, let's see, 6,800 is about, we're going to have to round it a little bit, 82.5. Okay, that's one diagonal. We want to find the sum of the diagonals, so we need to double that. So 82.5 times 2 is going to be about 165 meters. Okay, last thing on here is your triangle line segment review, because you guessed it, these don't ever go away, not until you know these cold. So underneath each one of these, you have a drawing of triangle line segments and their point of concurrency, which is where they intersect. So on the top line, write the triangle line segment. On the line underneath it, write its point of concurrency. Do that for each one of these, and we will take a look at them tomorrow. As always, if you have any questions, make a note of them, and you can ask those in class also. See ya. Thanks.